Hey everyone, welcome to Observe and Resolve, your go-to series for troubleshooting and analyzing cloud-native technologies. I'm Henrik Rexed, and today we are diving into one of the hottest topics in the cloud-native world, sustainability. Why is sustainability so important? Well, first, the adoptions of cloud-native technology like Kubernetes is skyrocketing, and we all used to host our workloads in the cloud. Second, our society is increasingly dependent on software for everything. Third, AI is booming and organizations are integrating AI into their platform to enhance user experience. As a result, the carbon footprint and energy consumptions of data centers are exploding. We are almost consuming more energy than the airline industry. The alarming part is that this usage is expected to grow by 3 to 4% per year due to AI workload. So we need to act now. But how? There is a clear journey for this. We need first to measure our actual energy consumptions. Even if it's just an estimation, we need at the end a KPI to guide us. Second, we need to include energy usage in our pipelines to block workload that consume excessive resources between releases. 3, optimize code that consume excessive memory or CPU cycles with the help of profiling. 4, turn off unnecessary environments in non-production environments. So, how can we report energy usage? There is an interesting project in the CNCF landscape called Kepler. Kepler is designed for Kubernetes. Kepler estimates the energy consumptions for our workload using eBPF. The eBPF probe collects CPU, GPU cycles, memory allocations, and estimates the energy usage of our workload. At the end, it's a Prometheus exporter. The only challenge with Kepler is the high cardinality of the metrics it produces, due to adding the process ID as a dimensions and also container ID. So how can we resolve this? Here is what we'll do in this episode. First, we're gonna scrape the Kepler metrics using the OpenTelemetry collector. Then we will use OpenPipelines to transform the collected met. 3, we will build a dashboard for Kepler. What about the Observability setup? To get started, we will need few things. We will set up Kepler using the Helm chart, deploy the Dynatrace distro for OpenTelemetry to create a metric pipeline collecting Kepler metrics. We'll deploy the Dynatrace operator to monitor our Kubernetes workload. We'll need to define the right open pipeline. Before ingesting the metrics, we need to pay attention to the Kepler metrics. They have dimensions or label with a high cardinality, which are not useful for our use case. To avoid exploding the metrics usage in Dynatrace, we'll create an open pipeline that will drop the unnecessary fields, so the process ID and the container ID. On the other hand, on our OpenTelemetry collector pipeline, we'll add extra resources to the metrics to help us trigger the open pipeline, only of course for the Kepler metrics. We will limit the enrichments on the collector of the metrics to only to the Kubernetes nodes and cluster ID, as we want to utilize the dimensions provided by Kepler, container names, container namespace, and pod name. We also explicitly drop all the metrics that we don't need directly at the collector level. Once we have the metrics configured, we can start adding the rest of our logic in Dynatrace. So let's open OpenPipeline, create a new pipeline for the Kepler metrics, and we're going to use the DQL processor to rename the fields and remove the expensive dimension. Finally, we will configure the pipeline route to match our Kepler source, ensuring our metrics are properly structured and of course indexed. This will help us in building a relevant dashboard. Let's now open the dashboard to report the various energy usage of our namespace, containers, and more. If you want to try this out in your environment, check out the GitHub repository that has all the instructions. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more episodes of Observe and Resolve. Thank you for watching, and see you soon for another episode.